Did anybody back in like the late 90s or early noughties, I think they're called, write a HTTP-based web-based chat system where you'd have like a, so you've got this little modal dialog box or something that pops up and you can start typing and it would send it to the server and the server would log it, and then other people who had logged into the chat would say, hey, are there any new messages for me? So you've got this send and receive thing going on, and the server is the central point of all the data, and it stores all the information in a log file, and it reads and it writes. And then you've got to think about taking into account things like, well, when user 2 says, I'd like to know what other text messages have come through, when is that from? So you've got timestamps, or maybe similar to a commit hash, you might have a way of signifying my last message was here, I want everything since then, but you've got to then handle that communication. And then you've also got the log file, like it's going to grow out of control. Do you use a database? If it's really popular, how are you going to scale that? So what would be really nice is just to use sockets and talk. So we've got WebSockets and WebRTC and those kind of things, which are kind of cool. And this is the kind of thing you can do with React and Ratchet. So, oh, and also, we can still log. I'll show you how that logging then just becomes a sideline action that happens. So, React. Let's go down to this one here. So, we have, this is the default setup that you get when you install Ratchet. Ratchet and React are both installable via Composer, which I love. Has anybody here not used Composer? Good. It's fantastic. So the way it works is you've got a bin directory, which is where your binary executables go. And if we have a look in there, I've just got one file called server. And essentially what this does is it just pulls in the libraries it's going to use, creates a new I/O server on port 8080, and it passes into it an instance of an object that is able to handle requests. That's it. And then if we have a look at, where was it? I think it's in source, my app, chat. Do I have that open still? I do. So here's the chat class, and essentially you're extending message component interface, which is part of the Ratchet framework. And what I want to do is we're going to have a number of clients talking. So I'm going to store in private space a list of clients, which I'm setting up as to be an SPL object storage, so I can add clients and remove clients from this pool of clients so that the server knows who's talking to whom. And there are a number of built-in, am I crackling? Am I talking too loud? I heard a bit of, no, all good. There are a number of methods that you need to implement when you use the message component interface. The first one is on open. So when a connection comes in, this method gets called. And what we're going to do is attach the connection that comes in to the list of clients. I'm just going to output a quick line saying somebody connected, just so we've got information on the command line to find out more about it. And then we've got on message. When a connection sends a message to the server, what do we do? So in this case, what we're going to do is loop through every single one of the clients that's connected and say, if the message is not, if the client we're currently looking at is not the client from whom the message came, then to that client, send the message. So this stops user 1 getting his own messages. So this one line here, that's the logging. So I can take that out and stop the logging. We're no longer reliant on logging being a mechanism for providing the messages back. It's all in real time. If you took that out, it would be a very lossy chat. There'd be no logging at all. Great for privacy, assuming, of course, you've got end-to-end privacy and security. And then finally on close, we're just going to pop that connection off the client, the pool of clients, so that we don't try and send it messages when other messages come through. So let's have a look at how this works. So I'm just going to run the server from the command line, and it doesn't say anything because there was nothing to say. Now, I've recently started using Terminator as my Linux-based terminal client, and it's kind of cool because you can have lots of little windows and you can even drag them around, but I'm not going to do that this time. But I just wanted to show you. So let's imagine that the red highlight is the current window I'm looking at. So let's imagine this is chat person 1 and this one over here is chat person 2. So I'm going to telnet to localhost on port 8080. I'm not going to make any HTTP requests at the moment because if you remember from the chat system, we weren't actually talking in HTTP, we were just sending raw messages from one client to another client. So this is pure text-based over port 8080. Going to log in, and we can see down at the bottom here, somebody connected. If I jump over to this side here and log in again, you can see somebody else connected. The message appears almost instantaneously in user 2's window. We've got a log here saying sending message, I am user 1. And if I then disconnect, just to prove it works both directions, if I then disconnect from this side here, we see that somebody disconnected. And if I send a message over here, you see there's no error because we're not trying to send to a connection that doesn't exist. So it takes the awesomeness of React, much easier to see what you're doing. If you compare with the original code that I was looking at, the curl one I think is probably the easiest way of doing it in the old style, where you get a known system that has robustness to make an HTTP request to a remote process, and that process that can then ensure that it runs no matter what happens to the original requester. It's probably the cleanest way of doing it. The detachment method, the second one I showed, means you've got all the code in one place, but it's not reliable. So this takes the awesomeness, or React takes the awesomeness of that. All your code is in one place, and you've got the clean object-oriented model of development. But it also uses the best of all of the old worlds of communication. And it adds WebSockets on top through Ratchet. So the React doesn't actually support the WebSockets. It's the Ratchet set of the Ratchet framework that sits on top of it that provides those. But you still face the same issues, memory overflow. I could do that in Ratchet as well. So where to from here? The loop itself, essentially because PHP isn't threaded or any of those things, it's actually still running a loop. It's just an event-based loop, and because it's not going through, because it's running within its own server, not through something like Apache, it's able to break out those events more easily, but it's still very slow because it's still processing it in a very procedural manner. So if you use something like libevent, which is a Linux-based library, it's external of PHP and Apache and all those things. If you install that, Ratchet will actually pick up the fact that it's installed automatically, and it'll stop using the PHP loop and start using libevent, which will increase the speed at which it's able to handle events significantly. When you deploy, one of the major issues with deployment is the fact that it is running on its own port. So you need to work out things like load balancing. What some people do is stick Varnish in front of it, and then depending on the kind of request that comes in, they would still all come in on port 80 or 443. Depending on the kind of request that comes in, which Varnish can detect, it'll either send it off to Apache Nginx, IIS, whatever you're using for your web serving, or to port 8080 or whatever you're running your React system on. And to solve the problem of the PHP process dying, there's a tool, there's a number of different tools, but the most prominent one is SupervisorD, the D being for daemon, which is the suffix in most Linux space applications to say I'm running in the background and I'm doing a tool, like a web server, for example. So it's basically a supervisor to make sure that your daemons are still running. So if you configure SupervisorD to make sure that React is running, then if React dies, it can spawn it straight up again. So you've still got that little bit of downtime, but it should be unnoticeable to most clients using the web service. Mathematics. So it's 35 past. I believe I have 10 minutes, so I can do some demos. Does anybody have any questions about what I've done so far? I can go back and do demos of the previous way that it used to be done, just to show the logging. Yes?
Does this approach introduce any challenges in terms of debugging? I know that switching over to some event loop systems, you end up with crash dumps that are impossible to
Sure.
make sense of.
So, so the question was, does it make it harder to debug when you're using this kind of a system? The problem with asynchronous development is that it happens in a time that is not equal to the time that you're monitoring it in terms of application debugging tools. You get the same issue when you use things like SOAP between remote systems, because there's a transaction bit in the middle and a translation process that happens somewhere. So it's always harder to debug when you can't actually step through the code as it's supposed to be running. The best advice that I have from experience with working with event-based triggers is just to do lots of logging. So you would have an event log somewhere that you are able to output object level dumps of information if you need to, or just line items in the way that the somebody connected, somebody disconnected happened, in order to be able to isolate the area they're working on. Personally, I haven't found any great tools for debugging in PHP land event-based systems. Has anybody else here found any that work? Event-based debugging systems for event-based programming in PHP? No. I think it's one of those things, it's the next hard problem to solve in event-based programming. Anybody else?
The initial example you gave with the taking an order, you've shown basically you make a request to the payment gateway, and while you're waiting for that request to come back,
Yep.
you're doing something else. So essentially you need to get the result back. So using curl or any other examples, you're just sort of making a call and then your script's terminating, whereas what you need is to go off and do something else and then collect the output, maybe update the order with a success or failed,
Yep.
and handle appropriately. Is React going to handle that sort of scenario as well, where you can truly be async?
Sure.
You're just offloading.
So the question was around this authorized payment part. You send off the request, you need some way of being able to collect the response again at the other end in event-based programming. So typically what you'd have is something like a callback. Does React support callbacks from remote systems for standard HTTP requests that's sent off? So imagine, say for example, and I'll pick on one of our sponsors, you're using the Braintree integration and you send a request off to Braintree, his head just perked up. You send a request off to Braintree, you've got to wait for that response to come back, but it's still a single HTTP request. And is React asynchronous enough to be able to background that and then get the information back? What I would do in React, and I don't believe there's a way of, unless you have any level of control over the remote system that's able to then formulate a response back, if you can tell it to call back, then no, because you don't have control over that system. And in the case where you don't have that, which is a fairly likely example, what I would do at this point here is I would send this whole process into the background somewhere. And I might then merge something like React with shell exec, where I would say in the background, run a PHP process that sends this request off to Braintree, and then when it gets a result, put it into this log file, and then within the React system. So the example I showed was with the loop function. There's also a timer function, so you can have every 5 seconds run this function. And every 5 seconds you would just say, has this log file changed? And then as soon as it's changed, you get that back, at which point you can then trigger this point here and continue the loop. So one thing I didn't cover, because I was storming through it, was even though we've started creating the order here, at this point here, if we get a negative result back, you could roll back the order creation. We haven't sent the email yet. We haven't dispatched it to the warehouse. We wait until the payment is actually confirmed before we continue. But there are things that you can do while you're while you're waiting for a positive response. And if you think of the odds of a false coming back from a payment gateway, it's more likely that payments are going to go through. Might be an interesting statistic to ask Steve about, actually. How many payments that are sent to a payment gateway come back with a reject, percentage-wise?
Yeah, but they always work with our gateway. No, that was the sales guy. I can get some numbers.
I was imagining it would be quite low, because most of the time people put in their correct credit card details, but maybe I'm wrong. But the cost of rolling back in the event that the payment failed is probably lower in the grand scheme of things than the cost of waiting to generate the order if the payment succeeds, I think. But again, that comes down to personal situation with your product and lots of testing, because we all do testing to work out what works best, right?
Can you just go back to the previous slide for that?
That one?
Yeah, that one you've got the create order before you do the authorised payment.
Yes.
All right. So do you still need to create the order before you even start the authorisation of payment? Or can you create the order while you're authorising? How does it know what you're ordering?
So the question here was, I started creating the order before I authorized the payment. Could I do it at the same time? If I did, that would be asynchronous, so not in a synchronous model. But I could do it the other way around. I could authorize the payment first and then create the order. But from a synchronous perspective, you're still taking the same amount of time.
Yeah, okay. Yeah.
But on this screen here, once I compact it up, we do the authorized payment first and then generate the order while in the synchronous view.
Okay.
Yeah. Kickstart, as many remote processes as you can first, so that you can use all the idle time to process things you can do, but make sure that dependencies are taken into account. You don't want to send off an order confirmation email and then have to send them another email saying, actually, no, your payment failed, sorry about that. Be rather awkward.
Just joking.
Have you heard of Rescue, or have you experienced with that?
Rescue?
Rescue, it's a kind of an asynchronous process handling library where you can spawn off processes and have Rescue run kind of worker processes for PHP tasks or code, which can be, say, managed by a main thread, or say like a queued job, or some other.
So is it?
I'm rambling. It's a way of kind of essentially forking processes and running tasks asynchronously. You can say, Rescue, do this, give me kind of a reference to this particular job, and I will tell you when I want to know kind of what the status of that job is.
Yep.
And that job will run in the background, doesn't need to be tied to a particular user request. It's essentially independent, and you can
So it's essentially like a management layer over the top of using something like shell exec. So you'd spawn all the processes separately, but you've got this management layer in software that allows you to interact with those and manage them.
You're not doing a HTTP request. You've got a library which handles that kind of abstraction of initiating the process for you and kind of reporting back the response.
Sounds interesting. How do you spell rescue? Standard?
R-E-S-Q-U-E.
R-E-S-Q-U-E.
What I really
if
want
anybody's
to know
interested.
is, have you heard of it, and what do you
Nope.
think of it?
I think it sounds awesome.
So, and it's not so much a question as a, hey, I've been using it and it's been awesome for kind of these kind of tasks and these problems I've had to solve in it.
Have you tried React or Ratchet at all?
No.
Okay. It'd be interesting to compare the two.
That's why I'm not talking about that, because that's I'll be speaking from a position of an experience. But
Yeah, no, totally.
I like Rescue.
I'll give that a try. Thanks.
And we've been using it on top of a Redis kind of value pair data store, so it kind of works with that.
Awesome. Let's catch up afterwards and have a bit more of a chat about that. Sounds good. Anybody else?
I don't belong to this PHP thing, so maybe that's...
Nobody belongs. We're all one big group of lovely people.
But it looks to me that Ratchet thing, you just created a server that listens to some requests.
Essentially, yeah. So there's a whole lot of Ratchet itself as a background library that supports that.
How does that compare to that FPM thing? Why would you choose one over another?
So the question of CGI FPM for PHP was around using the detachment method, where the PHP process could continue without any reliance on Apache. That's in the older model.
Yeah, but there's still like a server listening to somewhere, and you could use that for the same purpose, I suppose.
You could. You're separating your concerns then. So the advantage with Ratchet and React is that you've got almost like a single framework in which you put all of your business logic classes in order to perform. So it's all about, one of the things that I've been looking at is not only the usability and the stability of the systems, but also how maintainable are they. If you've got a really awesome system that has absolutely no downtime and responds to things really quickly, but nobody knows how to code it or which library or which repository of code to look at to make changes, then there's downsides to that as well. So I think it comes down to a case-by-case basis. There are definitely cases where you would want to have a custom-based socket service listening on a machine that did things really well, really quickly, depending on your business requirements. But if you're looking at building an asynchronous chat tool, I probably wouldn't go that far. So,
Oh yeah, chat is definitely...
yeah. So it depends on your needs, totally. There's no right answer. Anyone else? Well, in which case, I'll quickly skip to the end. Anytime. So there are the references. So this guy here, Software Gunslinger, PHP is meant to die. It's a bit of a play on words and it's about the process dying, but he talks in a bit of detail about how PHP is really not designed to be asynchronous and you never should. Then he talks a little bit about how you can, but you probably still shouldn't. So it's an interesting read from a naysayer's perspective. Methods for asynchronous processes in PHP has got some of the examples if you want to play around with them yourself. React and PHP themselves, I'll put these slides up so you can actually click on that link rather than just look at the link. But it's reactphp.org. and Ratchet, I think it's ratchet.io, but there's a link from the React site to that. And I'd like to thank Duovery for the picture of the Eggs Benedict. If anybody has any questions, I think I'm out of time and I need to move on. So please talk to me afterwards, unless it's very quick.
Thank you very much.
You're welcome. Thanks. Thank you. So I do have a quick